Which of these statements is false? What do you think? Well, read the options carefully, pause the video, and then move to the comment section and write the correct answer, or what you think the correct answer is: A, B, C, or D. So at this point, I encourage you to subscribe to our channel if you haven't done that yet, and then like our video and share with your friends. Welcome back. I'm sure you have chosen your answer and have written it in the comment section. So let's see, which of these statements is false? Well, the correct answer is D. Benzene undergoes addition reaction instead of substitution reaction. Well, how can you tell me this story? That is actually not true. It is a false statement, because benzene will actually favor substitution reaction ahead of addition reaction. So that is a false statement. And this is because benzene is very, very stable because of the presence of the delocalized electrons. So because it is very stable, it will rather like to substitute one of the hydrogens with any other atom, but not addition reaction. So our correct answer is D. But how are we sure that A, B, C are true statements? Let's look at the very first option. Benzene is more stable than Kekules benzene, and that is very, very true. Actually, the benzene we are talking about over here is actually the delocalized benzene structure, the one we know now, the modern benzene structure. And the main difference between the modern benzene structure and the Kekules structure is basically about the arrangement of the electrons and the bonds. For the Kekules structure, which was proposed in 1865, it was predicted that benzene has a ring of 6 carbon atoms with alternating single and double bonds between them in this way. Well, excuse my drawing. But one interesting thing about the Kekules structure is that the double bond here, which has a one pi bond here, is actually localized according to the Kekules structure. When we say localized, what it basically means that it is fixed between these two carbons, this carbon and this carbon. That's basically what the Kekules structure is trying to tell us. It is localized. So there is double bond, single bond. But the Kekules structure went on to suggest that benzene actually has two distinct forms, which can be interconverted through a process called resonance. So what it's trying to say is that this structure here can actually also exist in this form. So the only difference is that the double bonds have now moved to the next carbons. So this is what the Kekules structure is trying to say. So he has actually done a pretty good job at the time. But the basic understanding of the time was that the pi electrons or the pi bond was actually localized. But along the line, the delocalized benzene structure came along. The explanation is almost the same because it also represents benzene as a ring of 6 carbon atoms. And the structure shows that the electrons are actually delocalized evenly through the rings, not localized. So instead of drawing something fixed like this, the one we normally see in our textbooks, the benzene structure, according to the modern structure, which is the delocalized structure, it draws it this way, but with a ring between them. So this is the drawing of the modern delocalized benzene structure. So you realize that the pi bonds are not localized or are not fixed between any two carbon atoms, but actually represent them as this circle between the carbon atoms to show that the pi bonds are evenly spread in the entire molecule. And this is a representation of the delocalized electrons. And because of the presence of these delocalized electrons, it makes the modern benzene more stable than the Kekules structure, which means that this statement is true. Now, if you look at the B, both benzene and Kekules benzene are two different compounds with different stability. We know that this side of the statement is true. They have different stabilities. And then the first part of the statement, benzene and Kekules benzene are two different compounds. Actually, they are entirely different ways of representing the same compound, which is C6H6. C6H6. So the delocalized benzene structure represents it this way, while the Kekules structure represents it this or this. So that means we can actually say this statement is also true. Then the last statement, which is Kekules benzene is just like cyclohexatriene. This is a true statement. Let's draw the structure of cyclohexatriene and you see what I'm talking about. So the structure you see here is cyclohexatriene. Good. There's carbon over here. So how many carbons do we have? We have 1, 2, 3, 4, 5, 6. So that is where we got the hexa from. And cyclo from it being a circular structure. Now, if you see this side, triene is basically an alkene with 3 double bonds. That's basically what it means. And where are the 3 double bonds? We have 1, 2, 3. So Kekules benzene is just like cyclohexatriene. That is a completely true statement. So this makes this also true. So I hope by now you've gotten why we chose D as the correct answer. So D is the first statement out of the 4 options we have. Benzene actually will favor substitution reaction ahead of addition reaction. Subscribe to our channel. Tell someone about this channel, that is Learner's Aid, and then we hope to grow this channel with you. See you in our next question under organic chemistry.